Yeah. So very good morning, my dear students. So in today's class, we will just switch over to the module 3. Okay, yesterday I told you. So the module 1 we have completed, and today we will be switching over to the module 3. Okay, afterwards I will come back to the module 2 later, right? So in module 3, so we have very important concepts to discuss. So why? Because actually in module 1 we will be discussing only the basic concepts. Basic concepts in the sense which are very much required for us to design a component for manufacturing and assembly, right? So in the module 2 onwards, module 2, module 3, module 4, so we will be completely discussing. So our complete understanding of the concept is based upon the actual concept of design for manufacture. In the sense, so here what happens, so we will be discussing the design, how we can design the components based upon different manufacturing processes. So I mean to say here is, see, you can produce or you can manufacture the components in different means. There are different methods are available for us to manufacture the components. So for example, you can manufacture the components by using casting. You can manufacture the component by using machining or by using forming methods. Okay, and of course we do have fabrication methods also there, like just welding or riveting or brazing, like that. There are different ways in which you can produce the components, right? So as a design engineer, so and understanding the concept of a DFM, so you should be in a position to know so how we can design the components for a different manufacturing processes. In the sense, so you might have studied the design of components or design of elements or machine elements in your UG, and of course maybe to a certain extent in your PG. But all those things are corresponding to the obtaining these dimensions of a component, and once you get the dimensions, you can produce it in the form of a drawing, either it is in the 2D or 3D. So this is what you might have studied in your UG and PG in design of machine elements. Now, once you get those two things, that's not the only thing your design is over. So because that won't be what we can say, you might have not considered the cost into the account at that time. So because the cost is very important when you are producing a component. That's why I was just discussing in yesterday's class, so how you will go in to fix the MRP for a component. So as a design engineer or an engineer, you're supposed to be have an idea or have a knowledge of, so what are the cost elements that will be involved in making a component. So how we can fix the price for a component. So this is very important for a design engineer. So the reason why he's supposed to know, because the ultimate task of a design engineer is to reduce the cost wherever it is possible. I think I was just mentioning at the end of yesterday's class, that is, so the most almost 50 to 60% of the cost of the manufacturing a component will be based upon the material and the manufacturing processes, right? So material is almost, it will be contributing to around 25 to 30%, and the later part will be the manufacturing processes. So wherever it is possible to minimize, okay, so wherever we can able to minimize the cost, so definitely it will be contributing to the final price of the component. So this is very important. As a design engineer, you should be knowing, so where I can reduce the cost. So reducing the cost means only thing is you have to look it out for the newer material which are less expensive than the material what you are using at present. Okay, and wherever it is possible to avoid the machining processes or manufacturing process, so the same thing can be accomplished by different means. So adopting a different methodology or adopting a different what we call it as mechanisms, so like that. So you have to look it out for various things which is going to be happening in the world, and you should be have those knowledge, and you should be in a position to inculcate or to adopt all those things in your design. So that is the reason Why? The design engineer should be get needs to be updated everywhere, every time. So because he needs to have a vast knowledge of what's going on in the, especially in the research areas and in the new product developments. So all these things are very, very important for a design engineer. So that he should get updated with his what we call it as knowledge with respect to the manufacturing processes and the technology which will be available for him, so that he can adopt those things for his design of a components, right? So in that respect, so what we are doing here is in this module 3, so we will be discussing three important concepts. One is design considerations for casting components, one. And the second important thing is design considerations in welding. And the third important thing here is design considerations in machining. So three important manufacturing processes. So we have to consider, and in the sense, we being a design engineer, you should design the components which are manufactured by using casting. So when the component is casted, so how we can design for that? So what are the guidelines, or what are the recommendations that I supposed to give for manufacturing a component by using a casting process, right? And second thing, welding. And also same thing, the guidelines for design considerations in welding and design considerations in machining. These are all very important thing. Being a design engineer, you supposed to know. So what considerations I should make when I am designing that component which is to be casted, or which is to be machined, or which undergoes a what you call it as a joining process, like a welding or a brazing or a riveting, whatever it might be. Of course, so we restrict our discussion in joining process with respect to the welding only. So we are not discussing riveting and brazing, right? So here, uh, instead of course, first how we going to approach, or how we going to discuss this module 3 is, we will have first we are going to consider the design considerations for casting, welding, and of course machining. And once I just start with the casting, so we will going to discuss what are the different design considerations that needs to be involved, or to be used for designing the component for casting. And first and afterwards, we will have some machine components will be given. So those machine components we need to analyze, and we need to uh, design the component for the casting, and similarly for welding, and finally we'll go for machining. Okay, so the plenty of problems will be there in this chapter. Okay, so all these things will be depends upon uh, how we analyze. So understanding the concepts, and later part we need to solve or to analyze or apply those basic concepts to analyze the casting components. Okay, so let us just, this is what I wanted to give an introduction before I just start with the module 3 over here, right? So it is basically you will have two questions from this module. So two questions in the sense, of course, sometimes one only theory part is very less in this. So with the first question, theory part is very less. So maybe you might be getting a problem for 15 to 16 marks, one question. And in the second question of this, you might be getting around 10 marks for theory and 10 marks for problem. Just that they will go into differentiate, but majority of the marks out of 40 marks, definitely around 25 to 26 marks is given for numericals only. Okay, so we'll just discuss those things one by one. Okay, so now let us start now. Let's just look at here. Just a minute. Just a minute. Let us start with now. Let me just go about with module 3, and I will just brief about the syllabus. So I already given the outline of the syllabus, what we're supposed to discuss in module 3. So design considerations. So we have a design of components with the casting considerations. So in this case, we will going to discuss the basic concept of your casting, sand casting, what you have discussed, what you might have studied in your UG. So where we have pattern, mold, and potting line, and coating cored holes and machined holes, identifying the possible and probable potting line, casting requiring a special sand course, designing to obviate sand course. So this is totally, it is related to the casting components, right? And afterwards, so we will have welding considerations. So what are the requirements and the rules? So redesign of components for welding and case studies. So this is the first part. The second part is there given the component design with the machining consideration, link design for turning components, milling, drilling, and other related processes, including finishing process operations. So they have given the link design. So we have to take a link as one of our example, and we have to discuss the turning, milling, drilling, and other related processes, including finish machining operations. So the content of the syllabus is very less, but it includes a lot of problems. So it takes a lot of problems to be discussed because there are plenty of factors that needs to be considered while you are designing the components for casting as far as for machining. Okay, so we will go into discuss one by one. So before we just proceed for the problems, let us have a discussion regarding with respect to the concepts. So what are the design considerations that we need to be have while you are casting, while your component is being casted? Okay, so let us start with the things, right? So now, so this is a basic diagram. I think everybody has been already been studied these things in your UG. Am I right? Sand casting. So anybody can explain what is sand casting briefly? Yeah. Mithun? Mithun, are you there? Mithun?
Yes, sir.
Yeah. Mithun, can you just briefly explain what you understand or what you understand by the word sand casting?
It's a casting process where it is manufactured by using sand as the mold material.
Okay. Yeah. That's it?
Yes, sir.
That's it. You can tell about sand casting. Okay. Sandesh?
Yes, sir.
Yeah. Sand casting.
It's cheaper also compared to press molding.
Okay. No. My question is, so if someone comes and asks, can you explain what is sand casting? How do you go about?
So it is a metal casting process
Okay.
which uses sand as the molding material, sir.
Okay. Then, how do you do sand casting?
It basically has two parts.
Okay.
The
Which are those two,
patterns are the
which are those two
patterns.
parts?
Cope and drag.
Cope and drag. Okay. Then, Yeah, go ahead, bud.
The patterns are splitted into two pieces, sir.
Okay. Then
Uh,
what is pattern?
which has to be molded, which has to be casted.
Which has to be casted. Pattern.
It's
Replica of
a
the object.
replica of the object.
Yeah, replica of the cast. Okay, right. Then anybody wants to continue? Mohan Ambal?
So,
Yeah. So they told there are two parts. One is scope and drag, and Sandesh mentioned pattern. So anything to continue here regarding sandcasting? Now, if someone comes, your friends or so those are studying the third semester mechanical engineering, they ask you to explain what is sandcasting. Briefly, I don't want elaboration and explanation is not required for me. Briefly, how do you explain sandcasting? No idea. How do you forget casting method? Okay. Sukrut, are you there?
Yes, sir. Yes, sir.
Yeah. Would you like to add anything to this?
Concept. Sir, it is a relative cheap process, and it
Okay.
is sufficient refractory even for a steel foundry use.
Okay.
And in addition to sand, a suitable bonding agent is also mixed aqueous with the sand.
Okay. So you're not getting my question, Sukrut. Why? My question is, can you explain sandcasting process?
Sir,
Yeah. You know how?
sir, it's pouring of a molten metal to the mold, sand
Now,
mold.
how do you get sand mold? Where will be the sand mold? You might have done your foundry forging lab, right?
Yes, sir.
You
Yes,
might
sir.
have done these castings. You might have done the mold cavities, sand mold cavities. So how
Yes,
is
sir.
it done?
So
pattern.
we'll keep.
Yeah. Sandesh.
So we'll first place the drag on a flat floor,
Okay.
and we'll fill it with molding sand,
Okay.
and we'll place and we'll make that sand flat
Okay.
by using runner and all,
Okay.
and we'll place the pattern and
Afterwards, huh?
yes, other half of the pattern are placed in the drag, sir.
So
After
first
that
you
we'll
keep the pattern and will fill the sand, or will fill the sand and afterwards we'll keep the pattern. Which one? How?
other half in the cope.
No, pa, I'm asking you the drag only. In the drag, whether first you will keep the pattern and then you are going to fill the sand, or first you will fill the sand and
We'll keep
afterwards.
the pattern.
Huh?
First patterns.
We'll keep first
Yeah.
the pattern, then we'll fill the sand.
Yes. First you have to keep the pattern and then you have to fill this drag with the sand. Next, another half is in the cope, right? Then what you will do?
We'll apply some parting.
We'll remove the pattern, sir.
You have to remove the pattern first. Then once you remove the pattern, that cavity will be there. Then you will going to keep the cope over the mold box or drag box.
We
So
make
then,
the vent holes, and for mold pouring, we'll make a passage for that, sir.
very good. Yes. So afterwards, you will go into reverse the cope and you will go into place it over the drag. and later you will going to make the runner and riser, and you will going to have the gates also, and you will going to make the vent holes.
Yes, sir.
That is the basic procedure in making a mold cavity, sand mold cavity. Right. Afterwards, after you got a mold cavity, what's the next thing?
Molten metal is poured to the passage, sir.
Cavity.
Cavity, it is
Through where?
until
Through where?
Riser.
runner,
Pouring cups.
Through runner. Through runner. Okay, then what is
until
the
it reach the end, until it flow out of the drag, we'll put it, sir.
until out of it drag? How it will go? How do you come to know that molten metal is coming out of the drag?
Will be created a razor at the other side of the drag, no, sir.
Very good. Yes, that is the way. That is the basic things how we are going to understand the concept of sand casting, right? So once you get a mold cavity, so the metal from which you're supposed to make the casting is been heated to its molten state, and it has been poured through the runner, and we have to make sure, we have to ensure that the sufficient amount of molten metal has been filled the mold cavity. So you have to pour the molten metal until the molten metal comes through the riser. Okay. So once you pour a molten metal through the runner, so the molten metal flows into the each and every part or the corner of the cavity through the gate system or a gating. So you will have a gating will be provided. So through gates, the molten metal will go into flow and it will go into fill the mold cavity. Okay. So then you will go into come once you will go into continue pouring until you will see the molten metal in the riser. Okay. So this is what we will go into do, and you will go into allow the molten metal in the cavity to solidify for some time, and later part you will go into take out the casting from the mold cavity. This is the basic procedure. You might have studied this sand casting. Since the mold cavity has been made using a sand, it is called a sand casting, right? So of course you can have a metal molding also, you can have a metal casting also, where the mold cavity will be in the form of a metal. So that is also possible, but I am talking about only the sand casting, right? So this is the basic things I think you might have studied, and you might have understood the basic concepts. See, this is what the diagram what I am showing over here. The sand casting is defined as pouring of molten metal into a sand mold and allowing it to solidify inside the mold. Okay, so I think you can see the mold box over here. So there are two parts in the mold box. One is a cope, another one is a drag. And we will have a riser, we will have a pouring cup, that is nothing but a runner. Okay, and then we have a cast metal in the cavity, right? And I think you can see another one thing over here. It is called a core. Is it? Can you see this core, which is in the pink color?
Yes, sir.
Yeah. What is the use of core in casting? Anybody? Core.
So to provide internal cavity.
Very good. So make the holes. So generally the cores are provided to make the holes in the casting. So these cores are again, it is made with a sand or with made with the different materials. So whenever you have a component which has got a hole or an intricate shapes or internal cavities, so we will go into place the core, and then we will go into start pouring the molten metal. So that is the use of a core. Okay, so of course we can machine the hole also without using a core. Also we can do the casted parts can also be machined. Of course there are different ways in which you can make the holes also. Okay, So this is the basic concept. So I don't want to just explain these things. Already you will studied. That's what I want, everything from your side. So I think everybody understood what is the sand casting process. So this is a diagram what it has been shown with respect to the sand casting. Basically, it is a process of pouring a molten metal into a sand mold and allowing it to solidify in the mold. So this is what we call it as sand casting. All right. So now let us have this table, metal commonly used in sand casting. So look at this materials. It is generally metal. I was just talking about the metals, so which we will go into melt it to its molten temperature, and then we will go into pour it into the mold cavity. So when you look at what are the different materials that we are having which can be used for casting, especially for sand casting. So we have common metals and their tensile strength and their remarks. So this is also very much important for being a design engineer, knowing which are the materials are suitable for casting. This is also very important because we cannot make all the material to be used for making the casting. Okay, so this is the list. So we have a gray cast iron, and then we have cast iron, and we have ductile iron, right? So like that. So there are different uh, materials you can see, and their corresponding tensile strength also you can see, right? And then what the remarks. So what we have listed out here. So cast iron used for high strength is not used where high strength is not a requirement. I'm sorry. Best machinability, damping properties, and resistance to thermal stress. And similarly, when you come to the ductile iron used for auto crankshafts, hubs, pods requiring shock resistances, and like coming to the copper alloys for low pressure valves and fittings, hardware parts, brass, plumbing fixtures. So why I'm talking about these things, see, understanding, having a knowledge of a material is also very important being a design engineer. So particular metal, what is the particular application? So where we can use, because you are the one who will go into specify which material is best suited for that particular component. So because you are the one who will be knowing which is what will be the functional requirements and how this material has to function or it has to work once it is been put into an actual service, right? So this is what the different materials. Of course, you can get these things in your Google also. So when you Google it, so this is a one list of what very important for you to understand. See, because might be sometimes maybe using in our problems also. Okay, so aluminum, stainless steel, nickel, like that, different materials are there and corresponding tensile strength and their remarks. Okay. Next, so we will have a typical characteristics of a sand cast part. This is the one quickly I will just go through. A complex castings can be produced by the use of sand molds. So for example, intricate shapes. So when you had to have undercuts or complex contours, both internal and external can be made in the above method, which is generally difficult to machine for achieving such shapes. So in the sense, whenever we find the components are complex in the shape, complex means it is in the geometrically. So whenever we find it very difficult to machine that particular feature in that particular component, so generally we can achieve those things by casting method. Okay, so that's what they have specified, the intricate shapes, both internal and external. Okay, so where it is very difficult to machine achieving such shape, so we can go with the casting, right? And the metals, those who can be melted, can be used for casting this method. Table shows a list of commonly melted. That's what we have shown there. Further, casting of any size and weight, even as 200 tons, can be made in the above method. In the sense, the maximum the weight of the component are up to 200 tons, so which can be made by using casting technique. And the cast components are usually stable, rigid, and strong as compared to the products which are produced in other manufacturing processes. In the sense, the components which you make it by the casting, so they are stable, they are rigid, and strong. So three important properties: stable, rigid, and strong as compared to the products which are produced in other manufacturing processes. Okay. Generally, sand molds casted products are somewhat irregular and grainy surfaces, and hence machining is required to get a better surface finish. One of the major disadvantage of this casting is the poor surface finish. Okay, so once you get a once of especially sand molding or sand casting, we can call it as sand casting. These are will have some irregular shapes or some what we call it as these surfaces are not finished. So better surface we cannot be obtained by using this sand molding. So therefore, generally the sand molded pots or sand molded castings are being finished by using machining. Okay, so sand casting process are used in cylindrical blocks, machine tool beds, pistons, water supply pipes and belts, etc. So these are the applications of sand casting process, where it is used in cylindrical blocks, making cylinder blocks, machine tool beds, pistons, water supply pipes, belts and etc. So this is just I wanted to add some more characteristics of the sand casting process. Now let us start with the very important thing for us is design considerations and recommendations. Yeah, what are the factors that needs to be considered while you are designing a component for a casting? Okay, let us look at one by one over here. The following important recommendations are need to be considered while designing the sand casted products. First important thing is shrinkage. As the molten metal cools and solidifies in the mold, the natural shrinkage will occur. So I think this you might have, if you have done the casting in your when you are done when you have completed your foundry forging lab. So this you might have been experienced. See, all the material once it is been uh, heated to its molten state, they expand, and once it cools or once it solidifies at room temperature, so they will have a natural shrinkage will go into, a tendency to undergo a shrinkage. So means they will get shrinked. So the dimension of the casted product gets reduced as compared with the mold cavity. This is the one important thing. So when the molten metal has been poured into the mold cavity, the molten metal, once it starts solidifying, it gets shrinked. Shrink in the sense its dimensions or the size will going to be reduced as compared with respect to the mold cavity. The amount of shrinkage depends upon the type of material what you use. So this is another important thing. That's what I was talking about at the beginning. The knowledge of materials is very important for a design engineer, right? The amount of shrinkage depends upon the type of material. So different materials will shrink by a different amount. So you should be in a position to know, you should be in a position to decide which material is best suited for this product. And just so you're supposed to know, so the material will undergo shrinkage and what shrinkage allowance are supposed to give this for this material. Okay. In order to compensate the shrinkage allowance for outer dimension, the size of the pattern is made oversize, and for inner dimension like hole, the pattern is made undersize. This is a very important. See, the size of the mold cavity will depends upon the size of the pattern. Okay, once the pattern has been taken out from the mold cavity, the almost same size of the pattern will remains as the size of the mold cavity, right? So therefore, so as we discussed, the material will go into shrink on solidification. So we need to compensate that because we need to get the material or the component of that particular size or a particular dimension. Am I right? So if the once the component gets shrink and if it undergoes again finishing process through machining, so definitely the dimensions or the size of the casted component will get be totally smaller than that of the what actually we require. So therefore what we generally do here is we will going to provide the shrinkage allowances. Allowances will be provided over the patterns. So pattern will exact replica of the casting, what we call it as, right? So these patterns, so whenever we say the pattern is outer size, outer dimension, across outer dimension, the size of the pattern is made oversize, and for inner dimensions like hole, the pattern is made undersized. So this is a very important thing you should be in a position to understand, right? Next, it has been observed that the shrinkage happens towards the material side. The table below shows the shrinkage of various metals commonly in cast molds. See, this is how the material will go into shrink. Okay, so the different materials they have given the allowances. See, gray cast iron and white cast iron, it is almost 2.1%. They are going to give the shrinkage allowance. Aluminum, bronze, manganese, bronze, like that. There are different materials are there, and their corresponding allowances, shrinkage allowances should be provided over the patterns. Okay. Next comes the second important thing. So once the first one is a shrinkage, second one is the potting line. I think this also you might have studied in your casting process. What is a potting line? The potting line is a continuous line around a pot that separates two halves of the mold. Straight potting lines are more economical than the stepped potting lines as shown in the figure. So this is what we have, the pattern they have made. See, look at here. The potting line is a continuous line around a pot that has separate two halves. So I think when we are discussing the sand casting process, so we discussed two different mold boxes. One is a cope, another one is a drag. Am I right? So cope will be placed over the drag. So we're going to place the two halves of the pattern on each on the one on the cope and one on the drag, and we will going to keep a cope over the drag. So the line of separation between the cope and the drag, that line we generally call it as a potting line. So potting line is very, 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 very important in casting. Okay. So further classes, I think we're going to understand how to identify the potting line, which is a probable potting line, and which is the possible potting lines. This we will going to discuss that later part. Okay. So they generally these potting lines should be very straight. So the stepped potting lines are never preferred. Please keep it in your mind. I think this sketch you can see here is, see the potting line. See, this is the one potting line you can see. So there we are see here, the potting line is in the form of a stepped one, which is not recommended. So when you look at over here, the potting line is totally straight. This is the one which is recommended for us always. So please, being a design engineer, please design the component for casting which is having a potting line which is always a straight. Okay, this is the second important thing. Next thing is draft. So I think this also you might have seen, you understood. For easy removal of a pattern from the molding sand, some degree of taper or a drafts are provided. With the provision of a little or no draft, there are chances that the pattern may damage the mold rather than slipping out smoothly. So in the sense, say when you want to take out the pattern from the mold cavity, right? So it is very easy. You have to retrieve the pattern in such a way that they should not disturb or it should not affect the mold walls, mold cavity walls. So because once the pattern needs to be removed, you should be very careful, and very carefully you have to take out the pattern from the mold cavity so that it should not disturb the mold surfaces. So therefore, what we will do generally to make it the easy removal of the pattern from the molding sand, some degree of taper or drafts are provided. With the provision of little or no draft, there are chances that the pattern may damage the mold rather than slipping out smoothly. So therefore, some angle, some taper will be provided across the pattern so that the pattern can be easily removed from the mold cavity. So this is another one important thing in the design of consideration is that draft. So draft allowances should be provided in the pattern. And the next one is placement of risers. See, generally we were talking about a riser and a runner. See, risers are generally attached to the heaviest section. Heavier sections are closer to the riser and the thinnest sections are furthest from the riser due to the faster solidification at thinner sections. So in the sense, so generally where we supposed to locate the risers, this is a very important thing. See, generally, the risers are generally attached to the heaviest section of the component. So therefore, the heaviest sections are closer to the risers, whereas thinner sections are furthest from the riser. The main reason for that is the thinnest sections will go into solidifies faster than that of the thicker section. So this will minimizes the chances of getting wide. So therefore, very important thing is the riser should be attached to the heaviest sections. So this is what they're saying. This is the not the way you can put it. So this is the way. See, this is the heavier section. Okay. Next, coming to the ribs, I will just take this last thing. So one quiz is there after this. You can attend the quiz. Stop at this point. I feel okay. I will stop at this point. I will continue in the 4th hour, so you can join with the same link. Okay. So let me move on to the Google Classroom now. So we'll have a quiz over there. So any clarification, my dear students, with respect to this? So I will going to continue this in the 4th hour class. So if you have any clarification, we will go to discuss there. It's already 9:20. So I think it will disturb other class also. Okay. So I will come back to that later. So let me move on to the Google Classroom. I will just assign one simple quiz is there. So you can attend that quiz today. Yeah. So it is assigned. So you can start answering that quiz. And once you answer, please log out. And you can join for the next class. Okay. So we'll meet on 11:50 with the same link only. You can join for the class. Okay. Thank you.
Thank you.